Today we're going to talk about tables of values, not these kinds of tables that you see in the picture, of course. Example 1, complete each of the following tables of values, then sketch a graph. So this is a table of values, and you've done these before. You maybe called them T-charts. The important lines when you're drawing it yourself is this vertical line right here and this horizontal line right here. You don't need to box it in the way I have. The first thing I have in the table, X is always along the top and Y is beside it. So we have X and Y. First, I want to find out what Y is going to be when I'm given X. So I've been given all these values of X here to start with. -2, -1, 0, 1, 2. So these are all my X values, but I don't have any Y values. So I'm going to take my X values. My first one is X is -2, and I'm going to sub it into this equation where the X was. So instead of writing, well, let me start the equation. Underneath, I'm going to put Y equals -2, but instead of X there, I have to put in what I'm substituting, which is a -2, and I'll just use red to show you that, squared. So that gives me Y equals -2. Order of operations, I have to do the power first. -2 times -2 is +4. So I get a Y value of -8 there. So let's try that again, this time with a different X value. This time I'm going to use the X value of -1. So X is -1. I'm going to sub that in here. I get Y equals -2, and instead of X, I'm subbing in a -1 this time, squared. Y equals -2. -1 times -1 is +1, so I'm kind of out of room. I'm going to put it on the side here. My answer is Y equals -2. Let's do another one. Y equals my equation. I'm always going up to my equation. -2, but instead of X, I'm putting in a 0. So 0 squared is, of course, 0. -2 times 0 is 0. I get Y equals 0. How about 1? Going back up to the equation, Y equals -2 times 1 squared. What is 1 squared? 1 squared is 1. So my answer here, when X is 1, I'm going to get a Y value of -2. One more. Y equals -2 times 2 squared. So that's Y equals -2 times 4. So I get Y equals -8. So I have found here for all of these X values, I have found their kind of partner Y values. But how do I take that and graph it? So I've got X values of -2, -1, 0, 1, and 2. Those are going to be written along the X-axis here. Now I want to spread them out. I realize I could just put -2, -1, 0, 1, 2, but it would be kind of crowded. I want to spread it out a bit. So I'm going to count by 0.5s, but I'm only going to label every second one. So that's 0, 0.5, 1, 1.5, 2, and that's really as far as I need to go, but I'm going to just put a few more on here. Now on the negative side, my first line, grid line, would be a -0.5, so my next one's -1. And again, I'm only labeling every second one, and that's so that I don't get crowded. If I start putting in all of these numbers here, -3, -3.5, I can barely tell them apart. So I'm not going to label them all. That's why I'm choosing just to label every second one. -2, -3. I've got some extra little marks here. I want to erase those so they don't confuse you. -4. Okay, now how about the Y-axis? What am I going to put here for the Y-axis? Remember, these are my Y values that I found. All of these, Y equals -8, Y equals -2. These are all my Y values. So I need to fit all the Y values on here. The lowest one I've got is a -8. I've got it twice, so I've got to get down as low as -8 down here. And the highest number I have, looking over here, is a 0. So I'm not even going to have any of these numbers here. I'm still going to graph them out. But because I want to fit -8 down here, I'm not going to count by 0.5s as I did on the X-axis. I'm going to count by ones so that I can make sure I can fit everything in. So my first would be -1, but I'm going to again label every second one. Just it makes it faster and it also makes it a little tidier. There's -8. And I'm going to, I can't just ignore the top of my axes. It's bad form to do that. So I'm going to put some numbers up here. And there's oftentimes in your homework where you graph one and then you're asked to graph another parabola right on the same space. So we need to make sure our grid is ready to go. Okay, now we can sketch the graph. We've got our axes labeled, we've got all these numbers. So how do I take these numbers and turn them onto something I can put here on the graph? Well, let's use blue. My first x coordinate is -2. The y coordinate that goes with it is a -8. So my first coordinate is -2, -8. So I'm going to put a dot right there. My next coordinate, its x value is a -1. And the y value I got was a -2, so I've got -1, -2, another dot right there. So just looking at the x values, I'm just going to look at the x column here. I'm going to list all those first. The x values always go first, so there's a 0, 1, and my last x value is a 2. Now I'm going to look at my y values. These are all my y values that I had to figure out, and I've already got 2 of them. So these are the rest of my y values here, 0, -2, and 8. They're going to go in these spots here. 0, 0, that's the wrong color, blue. 0, 0, 1, -2, 2, and -8. So 0, 0 gets put on the graph. That is the origin. That's where the axes intersect. 1 and -2. And 2 and -8. So that is, of course, a parabola. And we know it's a parabola. We know it's that U shape because the equation, remember the key features, the equation has an x to the power of 2 in it. So it has to have that bend, that curve. It's not a line, it's a quadratic. So let's connect the dots, and it's got to be a smooth curve. I like to start at do a vertex and do half of it first. So I curve out of the vertex and curve down, and I need to hit all the points. And I curve again, trying to hit all the points. I don't have to go right through the middle of the points, but make sure to hit them. That is my parabola, and the equation of that parabola is y equals -2x squared. So let's talk about some of those features from before. First of all, the vertex. Remember the vertex? You had vertex on a triangle, and that was a corner. It's the same idea here. It's a corner. It's right here. That's my vertex. And what is the coordinate? Vertex is always written as a coordinate, not a number. You would not just say my vertex is 0. The coordinate of my vertex is 0, 0. How about the axis of symmetry? The axis of symmetry is that vertical line that we're going to draw that's going to cut it in half. So it's going to go right down the y-axis. I'm going to draw it just a bit beside the y-axis because it's hard to see on top of that black axis, but it really should be right on top of that axis. That's my axis of symmetry. That's the vertical line that I could fold my paper in half and my parabola would line on top of itself. It has an equation, and remember there's the letter x in axis, so my equation starts with x equals, and all I really need to do is take the x value of my vertex, x equals 0. That's the equation of my axis. So the equation of this purple line here is x equals 0. That's the equation of the axis. Next example, I'm going to use this table of values to graph, and I'm going to put my graph right here. But look at my equation this time. It's more complicated. It has 2 x's in it. It's got an x squared here, and then it's got another x here. So I'm going to have to be careful. These are the x values I was given, so I have to sub them in one at a time. So looking at the first one, I've got x equals 5, and I want to sub that in for this x, but I also have to sub it into this x. Let me write the equation right below. There's my y equals, instead of x, and I'll put this in green here, I have to put a 5, and always substitute using brackets, please. Minus 6 I can't just put a 5 there, it would look like a 65. I have to put brackets around the 5 and then plus 8. So now what do? Well, we have to think of the order of operations. And the B part of BEDMAS means what's inside the brackets. So if I had 3 plus 5, for example, to the power of 2, I would have to add those first and get an 8, and then I could square it. But when I look at these brackets with a single 5 in it, there's nothing to do. There's no order, there's no action I can take inside the brackets, it's just a 5. So next thing I'm going to do is go to the E in the order of operations, which is exponents, and that's going to give me this 25 right here. Since that's the only exponent, I am going to go ahead and do my division multiplication. That's minus 30 plus 8. And what is 25 minus 30 plus 8? You can use your calculator if you want to. It's 3. So what I've got here, after all that work, I had an x value of 5, and I got a y value of 3. So I have my first coordinate. Now I'm going to go and do the same thing with my second coordinate. I have an x value of 4 this time. So the 4 goes into this x and it gets substituted into this x, always with brackets. So back up to the original equation, 4 squared minus 6 times 4 plus 8. That's going to give me 16 minus 24 plus 8, and you may use your calculator if you want to. What do you get here? Interesting number, you're getting a 0. So my coordinate, my x value was a 4, my y value was a 0. So that's the coordinate that I'm going to graph. Now, if you think you're getting the hang of this, you don't need me to go through every step of the table of values. You can go ahead, you can press pause and go ahead on your own. I will do one more with everybody and then I'll let you do some on your own. Y equals, is always substitute with brackets, 3 squared minus 6 times 3 plus 8. 3 squared is 9 minus 6 times 3 is 18 plus 8. We get a -1. What's the coordinate? The x value was a 3, the y value is a -1. So I want you to press pause now and do the last 3 on your own. All right, please check your coordinates and make sure that you got the same thing I did. And if not, take a look at the math here and see. And maybe we've made a mistake. And if we have, we will find out very soon when we go to graph it. So we've got to label our x-axis first. The x values we were given are here. We were only given positive x numbers, but I'm going to label my both sides. So first of all, I'm going to count by ones, but I'm going to label every second one just so that it's spread out and I'm not crowded. Even though I have no negative x's to graph, I'm going to put them on anyway because it's proper form, and you're often asked in homework questions to graph more than one parabola on one set of axes. So we need them there anyway. Now what am I going to put on for the y-axis? Well, here's all the y numbers. Remember, all this math was finding the y values. I've got a 3, 0, -1, 0, 3, 8. So my biggest number is an 8. So I just have to count up here to 8. So I'm going to also count by ones, but I'm going to label every second one so that it's not crowded and so that I can work a little faster. So this is my y-axis. Also, don't forget the negatives. And now we put the points on. So 5, 3, my first point that I got is 5, 3. So that means starting from the origin, I count 5 to the right and then up 3. There's my dot. My next coordinate is 4, 0. So starting from the origin, I count over to the right 4, and then 0 means I'm going nowhere. I'm not going up or down. My third coordinate is 3, 1. So from the origin, I go over to the right 3 and down 1. Then I've got 2, 0, so I'm going over to the right 2, and then I'm not going up or down. 1, 3 means to the right 1 and up 3. And 0, 8 means I'm not going anywhere on the x-axis, I'm simply going up 8. So does that look like a parabola? Well, it does. It's a little lopsided, but it does. Let's say I had a point I don't know, down here somewhere, I would know I made a mistake in my table, because that would not make a parabola. That would not make a smooth U shape. So I don't have any points like that. So I'm going to start at what looks like to be my vertex, this point at the bottom here. And I'm going to curve up like this. And I'm going to do the same on the other side. Curve up. This one goes a little higher on this side. That's okay. And then next question down here at the bottom says, what is the vertex? Well, the vertex is right here. That's my vertex. 3, -1. What's the y-intercept? The y-intercept is where I hit the y-axis. That's this coordinate here, where my x value is a 0. So my y-intercept is 0, 8. What are the x-intercepts? I have 2. I don't always have 2, but I do this time. I have 1 right here, and I have 1 right here. So my x-intercepts, I'm going to write them as coordinates. I've got one at 2, 0, and I've got another x-intercept at 4, 0. What's the direction of the opening? This one looks like a smiley face, so this one opens up. The open part is at the top. Now, max or min, remember that means two things. Is it a maximum or is it a minimum? First of all, the vertex, it's asking about the vertex. The vertex is a minimum, and the minimum value, the lowest value my graph gets to, the lowest it gets to is right here. Minimum at y equals -1. So there is a graph from a kind of complicated table of values. Example 2. The equation of the outer parabola is y equals x squared. So that's the red one. That's y equals x squared. The equation of the inner parabola is 3x squared. That's the black one, is 3x squared. Since the only difference in the equations is the coefficient, that means the number in front of the x squared, what effect do you think the coefficient has on the parabola? So let me color these so we can keep them clear. The outer one, the outer parabola is y equals x squared. That's red. The inner one is y equals 3x squared. That's black. The only difference in these two equations, the only difference is this one has a 3 and this one doesn't. So what do you think a 3 does, or what do you think this number does? Well, it looks to me like it made it skinnier, right? The red one is wider than the blue one. So what effect do you think the coefficient has on the parabola? Well, I'm just guessing right now, but I think that it makes it skinnier. The coefficient 3 made the parabola skinnier than y equals x squared. So this is my hypothesis. This is what's happening here. Now we've got a different scenario. Here's an equation of the outer parabola is y equals -x squared. So that's the red one. So the red one is y equals -x squared. And then the equation of the inner parabola, the black one, is y equals -3x squared. This time we changed the sign of the coefficients. This time it's a -3 and a -x squared compared to the previous one, which were both positive. So what do you think changing the sign does? So this question isn't asking what does changing the number do, it's asking about the sign. So what's the difference between these two and the other two that we just did? And hopefully what you're thinking is something like, well, this one's opening down or it flipped down. And that's exactly what it is. And it's called a reflection. But we can say the negative in front caused the parabolas to open down. They are reflected or flipped. You could use any of those words there. So that's what happened when we change a negative. So those are a few more features that we now know about parabolas, and we're going to learn a lot about them. So good luck with your homework.